Okay, so what I have pulled up here is the ERC20 token contract pulled from the ethereum.org website, which has the token as a tutorial. And I figured we'd just kind of step through this and kind of discuss the syntax and see how it compares to the EOS token. It's twofold. Obviously, it's good to know where cryptocurrency came from and where it's going. So a comparison between the EOS token and ERC20 token is useful, of course, but more importantly, I think understanding the syntax between the two languages. So if you need to port your code over, you can easily do that. So that's why we're looking at it more so than anything else. So you can see here they have the symbol and the name here, very much the same way as the ERC20 token had, but that was built directly into an asset rather than separately as strings. Sorry about that. One thing to kind of notice here is, so we have the mapping, as I talked about in the previous video, from address to UN256, which is the address to balance, but you'll notice they can deal directly with addresses to balance. They don't need to do any extra stuff here, like getting account tables and looking up symbol names and or any of that other stuff, because again, this contract should only be for one token ever. So all you care about is this is the contract for this token. How many of this token does that address have? That's all you need to be concerned about. They have a total supply for that, very much the same way that we had here. When you were creating your new token with the exact symbol, you were giving it a max supply as well as an issuer. One thing to note is Ethereum has these events, which a lot of people are asking about. So when something happens on the Ethereum blockchain on an Ethereum smart contract, you can trigger an event, and that will inform UIs and other people on the blockchain that an event actually happened. Currently, EOS.io doesn't really have that same functionality. So what you're told to do by the Block 1 team is have your own database plugin that's filtering for transactions, and so it's a pull mechanism rather than a push mechanism. Whereas here, like when a smart contract gets something, it can push out an event and everyone can know about that event. Well, in the case of EOS.io, you have to constantly be pulling the blockchain, looking for transactions that are happening so you can inform your users about it. So that is one definite thing, in my opinion, a plus for Ethereum that exists. And that's how you do that in Ethereum. Again, how you would do that in EOS is a bit of a convoluted mess currently. Hopefully they fix that. So you see here we have a constructor for the ERC20 token. It's very kind of similar to the create that we had over here with the EOS.io token, where you're creating a maximum supply. Here they're giving you maximum supply, and then they're giving the total balance exactly to the sender, whoever creates the smart contract. Whereas here they're kind of holding off on making that assumption, currently at least. So you have to run the create method after that, rather than just assuming that the creator has the total balance of the total supply initially. From here, there's a transfer method. It's very much the same way as the transfer method for EOS.io, but they've learned a bit more lessons, it seems. I'm sure EOS will find there will be some bugs found in the EOS.io token contract, much the same way that there were in the Solidity contracts. So they know to check, okay, make sure nobody's burning their tokens unnecessarily, make sure that the balance is correct. All the same things that we saw in the EOS.io token balance example are in this example as well. And then here's how they are actually emitting that event to all of the users of the blockchain, saying, hey, this from user to this to user actually transferred this value. So again, that's kind of a useful thing to know about. And then again, they've learned best practices here, so they know that store the previous balances before you actually do the transfer, in order to like assert that this is actually correct before moving on. So we'll skip some of the filler contracts for now because I don't think they're terribly necessary. Another thing to note is, like, here you've got this the mapping, right? So it's very easy to manipulate currency in this mapping construct, whereas here it's a bit more of a pain, if you ask me, to subtract and add balances. The overhead of the multi-index really shows itself here. I mean, obviously the multi-index is much more powerful, much more, because you can store more data in there, right? Like they're able to do this asset style mapping essentially. This is, if you looked at it in the Solidity terms, this asset style mapping right here, because they're using a multi-index rather than just a hash table in the case of Solidity. But that's how you take value and give value to another account in Solidity. You can see down here they're subtracting a balance in this way in EOS.io, and then adding a balance in this way in EOS.io. Again, the syntactic overhead is a bit much, but you get extended functionality by doing that. Here they have transfer from, that kind of thing. We'll skip that again. We'll kind of skip the approval and allowance kind of stuff because it doesn't really exist in the EOS.io token smart contract, so there's not much we can glean from there really. Oh, another thing actually to kind of point out is here you'll see that returns bool success variable. Methods in EOS.io currently can't return anything. You'll notice that these are all void. So you have kind of no choice but to store return values in RAM, essentially storing them in tables and things like that. Whereas with Ethereum you can return data, and this is how you do it essentially. Okay, let's see what else there is. Oh, there's this burn functionality. So you can actually burn tokens and reduce the total supply in an ERC20 token, and that comes as a token standard. And you can see here in the EOS.io token there's no burn functionality. You could very easily write your own and deploy your own, of course, but and you would probably do it very much the same way that this is done here, where you're just reducing the total supply from the stats table, and then reducing the value in the user's account table in the EOS.io token smart contract. And so that's kind of the general overview of the ERC20 token smart contract, and a good comparison, I guess, in syntax between the EOS.io token. Obviously this is much shorter, much more precise syntax, Solidity is, but it's less well known, Solidity is, right? Everybody, well, not everybody, but most people learn some sort of OOP programming language in college. A lot of people are familiar with C++. Hardly anyone was familiar with Solidity. Plenty of people are familiar with Solidity now because of the growth in usage in Ethereum. But this, again, this ERC20 token contract is more succinct because it's doing less, right? It's only having to handle balances for one token and one symbol, whereas the EOS.io token smart contract is extensible to many different symbols and many different users, essentially. So that is a brief syntactic comparison between Solidity and C++. I hope you enjoyed it. Thanks.